Let's try to sketch polynomial functions. Now we will put all our learnings from power functions, from characteristics of polynomials, and see how to make a sketch of a polynomial function. Let's take an example. Here, let's say fx is equal to 3x, x plus 6 square, x plus 3, x minus 4, digit cube. Right. I have purposely taken such kind of an equation which has odd powers, you see, and even powers, all combinations, right? And then if we understand this kind of an equation, probably we will be in a position to sketch different kinds of polynomials. Let's first analyze this equation, okay? Now here, let's count the zeros first, okay? Zeros. And where are the zeros? Zeros. So we have zeros here when x is equal to 0. There is a 0, right? This. And when will this factor give a 0? When x is equal to minus 6. How about this? This will give us a 0 at x equals to minus 3. And this will give us a 0 at x equals to 4. If I put 4 here, it will be 4 minus 4, 0. And 0 times anything will be 0. And therefore, f of x will be 0 at this point 4. Similarly for all these points. So we have, these zeros actually represents our x-intercepts, right? So we have 1, 2, 3, 4 x-intercepts. Now let's try to find out what is the order of these zeros. Order, as we also said, is called multiplicity. So each zero's degree will give us the order, right? So here the power of this function is x to the power of 1. So here the order is 1. What is the power of this? 2. So this is of order 2. And here this is raised to the power of 1. So the order is 1. Here the order or multiplicity is 3. So this is what we have seen as, now this is a 0 of multiplicity or order 3, correct? Now you remember how will this behave on our curve? Order 3 will cross the x-intercept in this fashion, correct? And this will go like a line, and this will actually turn, right? And how about this? This will go like a line, correct? So this is the behavior of our 0 at the x-intercept, correct? Let's count the degree. Degree is 3 plus 1, 4, 5, 6 and 1, 7. So the degree is 7. You could also count degree from the order of zeros, sum of orders of zeros, correct? 3 plus 1, 4, 5, 6 and 1, 7, correct? And now we will calculate the leading coefficient. See, it is not important to find the value of leading coefficient. The sign of leading coefficient is enough to sketch our polynomials, correct? Sign of this x is plus, this is also plus, this is also plus, this is also plus. When you multiply all these x's, you will get a positive leading coefficient, correct? Now once we know all this, we can also calculate now leading coefficients and degree, as you understand, gives us end behavior, right? So let's see how is the end behavior of our polynomial. Tell me, how will it look like? We can make a rough sketch on the side. Rather, I'll just put the end behavior here. When we know that the leading coefficient is positive, that means what? Right side up. Do you remember that? Right side up means this. And degree is odd, 7. That means the graph will be in the opposite side, correct? So it will be going right side up because of positive and in the opposite way, right? So it is from quadrant 3 to 1. So this is the end behavior. This end behavior can be written as, when x approaches positive infinity, y approaches. When x approaches positive infinity, y approaches positive infinity. And when x approaches negative infinity in this direction, y approaches negative infinity. So that's our end behavior. Sometimes it may be good to see at the y-intercept. Okay, let's also see the y-intercept. Y-intercept. Y-intercept in our case, if you put x as 0, if x is 0, then what is the value of y? Y is, well, this x is 0, so everything becomes 0. So in this case, origin is our y-intercept, correct? So the origin gives us the y-intercept. Now this information helps us to sketch the parabola, correct? Oh, sorry, to sketch the polynomial. And now let's try to sketch this. Let me draw on a bigger scale. Let's say this is our coordinate system, okay? Now here, let's put all our zeros. So first zero we saw was at x equals to 0. Here it is, x equals to 0. Then we have at x equals to minus 6. Let's say 1, 2, 3, 4, 5, minus 6. So this is our minus 6, correct? Then we had at minus 3. 1, 2, 3. This is minus 3. Then we had plus 3. 1, 2, 3. No, plus 4. 4. This is at plus 4, right? So these are all our zeros, correct? This is at origin. Now, I'll see, just to remember how the graph will be. End behavior, we know. End behavior is this. That's our end behavior, correct? And on these zeros, what is the order or multiplicity of 0 at minus 6? At minus 6, it is square, right? The factor is x plus 6 to the power of 2. So here, if we are coming from this side, then it should turn. This is a minus 6, correct? At 3, we have a 0 whose order is 1. It acts like a straight line. So at minus 3, it will cross the x-axis in this fashion, like a straight line. How about at origin? At origin, also, the order is 1. So it will come back like a line, right? And at 4, we have order 3. It will act like a cubic function. So it will go like a cube, x cube type of thing, correct? So this is how our zeros are going to turn, okay, on the sketch. Now what we need to do is just connect them up to get a rough sketch of our polynomial, okay? So we'll do that. So here it is, see? Polynomials extend till infinity, right? It will go in this direction. And now we just connect this up. We'll say this kind of, do you see that? So it gets connected. And from here we go from quadrant 3 to quadrant 2, and we need to connect this, come back, because at 0 we have to come back like a line. So we'll just connect this. So here we are, and we go like this, and that's a line. And then the idea is to connect this. So let's go like this and do this. And from here we will make our curve like this. So that becomes the sketch of a polynomial for our function fx equals to 3x, x plus 6 squared, x plus 3, x minus 4 cube. Let's review it. Positive leading coefficient, right side up. Degree is 3, 4, 5, 6, 7. Odd degree function, opposite ends. So that's the end behavior, opposite ends. Correct? Now let's check from this side. This is our 0 at 4 with order of 3, cubic. So it behaves like a cube. Do you see that? This one is a 0 at minus 3 and behaves like a line because the degree is, or multiplicity of this is 1. This is the line. Here the 0 is minus 6. At x equals to minus 6 we have a 0 whose order is 2. It will turn like a parabola. Do you see that? and this 0 is at the origin, like a line. You see that? So connecting all the points, we get a perfect polynomial. Perfect. I hope you understand this. Now, let me give you some problems which you can try on your own. Let us say, try these functions. Let's start with very simple functions. We say, as an exercise for you, let's take a negative. This time as leading coefficient, let me say leading coefficient negative 5, x minus 7 times x plus 1 cube. So you can try figure this out. This will act like a cubic function at the x-intercept because this 0 has got order of 3 and the 0 is at minus 1. How about this? This 0 is at plus 7 with order 1. Will act like a linear function. This also will act like a linear function. Correct? But if I make this square, in that case, this becomes like a quadratic function. It will turn. Now, what is the degree of this? Degree is 3 plus 1, 4, 5, 6. So we say, let me write degree 3, 4, 5, 6. 6 and leading coefficient negative. Let me write an as negative. This will help you to sketch the graph. Degree 6 means, and negative this means what? Well, this means right side down, correct? So in your graph for this, right side is going to be down, degree 6 same side here. So that's the end behavior, and you can put the points inside and sketch as we did, right? Now let's take another function. I am purposely giving you functions in factored form so that it is easy for you to find what the zeros are, what is their order, and then counting the degree, checking the leading coefficient, and then figuring out the end behavior. Okay? So let's say we have equation x plus 1 times x minus 1 times x plus 3 times x plus 5. Now here, let me add some exponents to this. Let's say 4, 2, let me make it plus 4. How does it matter? So I have taken all on the plus side, so that means these are zeros will be on the negative side of our graph, okay? Very close, and degrees are different, right? So it becomes 1, 2, 3, 4, and 4, 8. And let me add one more, or let me make this as degree 2. So it becomes odd degree. So what you can do is create your own functions. What I'm trying to show you here is just create your own functions and try them out. Okay? You should be in a good position to draw. I'll give you a few more examples and sketch few more polynomials with different degrees and coefficients, and I hope by that time you'll become an expert on sketching polynomial functions. Okay, great. Thanks.